In this video, I want to walk you through how to balance an equation. I'm going to walk you through my method. Some of you will be able to see these equations and balance them without writing down a whole lot. Some of you are going to need kind of an organized approach to balancing equations. And so I want to give you my organized approach. It's kind of a guess and check method with some organization built in. And so I want to start with a fairly simple equation first, and that is hydrogen reacting with fluorine to produce hydrogen fluoride. And so the equation for hydrogen is H2. The equation for fluorine is F2. And the equation for hydrogen fluoride is simply HF. And when I balance the equations, I'm going to draw a line kind of down the middle to separate reactants and products. And I'm simply going to count and list out how many of each type of atom. So on the reactant side, there are 2 hydrogen atoms. And on the product side, there are 2 fluorine atoms. So I'm just going to put that under those like that. And then on the product side, I've got H and F, and they're together. And I've got 1 hydrogen and 1 fluorine. And since they're together in a compound, I'm going to put a bracket around them, because whatever coefficient I end up putting in front of HF is going to apply to the hydrogen and the fluorine. So I'm going to go ahead and make a blank in front, because that's where the coefficients are going to go. So I'm going to start at the top with hydrogen and compare what I have on the left side to what I have on the right side. So I've got 2 hydrogen on the right, and I've got 1 hydrogen. Sorry, I don't know my left from my right today. I have 2 hydrogen on the left and 1 hydrogen on the right. And so if I make this a coefficient of 2 in front of the HF, then I've got 2 hydrogen and 2 fluorine. Well, I just balanced the hydrogen, so I'm going to put a little check mark by that. Now I'm going to check the fluorine. On the left, there are 2 fluorine, and now on the right, there are 2 fluorine. And so when I balance the hydrogen, I also balanced the fluorine. So now this coefficient has to go up here, and that's a 2. Now in the simulation, they had coefficients of 1. You don't have to put the 1 there, but I'll just put it there for now. In the next example, I won't do a 1 if the coefficient is 1. That is now an example that is a little bit more involved. So carbon disulfide plus oxygen gas produces carbon dioxide gas and sulfur dioxide. And so again, I'm going to separate it down the middle, and I'm just going to list out the atoms. I've got carbon and sulfur together in a compound. So there's 1 carbon, 2 sulfur. I'm going to put the bracket around it because it is in 1 compound, because whatever coefficient I put out in front is going to affect both the carbon and the sulfur. There's also oxygen on the reactant side. There's 2 of them. Then I have carbon and oxygen on the product side. 1 carbon, 2 oxygen, and the brackets around it because they're together. And then I have sulfur dioxide, SO2, 1 sulfur, 2 oxygen, and again brackets because the coefficient will affect both of them. So now where do I start? Where do I begin when I balance this? Well, I'm never going to start with oxygen, because oxygen appears in too many places and it's just too hard to keep track of. I want to start with an element that appears in the fewest number of places. So that to me looks like carbon. I've got 1 carbon on the left, and carbon appears in 1 place on the right, and there's only 1 of them. And so the carbon is balanced. So I'm going to move on to another atom. I'm going to move on to sulfur. There are 2 sulfur here on the left, and over here on the right, there's only 1 sulfur. So that looks to me like I might need a coefficient of 2 in front of SO2. So that would give me 2 sulfur and 4 oxygen. Well, now I fixed sulfur, that's good. Oh, and I forgot to check that I had done carbon. Carbon is balanced. All right, so now what do I have left? I have oxygen left. And this is where you've got to pay close attention. You've got 2 oxygen on the left side, and you've got 6 oxygen, right? 2 of them with carbon dioxide, 4 of them with the 2 SO2s. So I've got a total of 6. If I have a total of 6, that means I probably am going to need a coefficient of 3 here to get me 6 oxygen on the left side. So now when I put the coefficients in, I'm going to put the 3 and the 2 in. The 3 goes up here with the oxygen, and the 2 goes up here in front of the sulfur dioxide, and now I have balanced that equation. And so one more reaction here, Al4C3 plus H2O produces CH4 and AlOH3. Again, my line down the middle is separate. I've got aluminum and carbon together, 4 aluminum, 3 carbon, putting the brackets around them. I've got H2O. On the right side, I have CH4, 1 carbon, 4 hydrogen. And I've got AlO and H on the right side, 1, 3, and 3. So where do I start? Well, I'm going to start with aluminum because I can see right away that my aluminum is not balanced. I have 4 aluminum on the left side, 1 aluminum on the right side. So if I make this a coefficient of 4, let me put my blanks in there for my coefficients. So if that's a coefficient of 4, then I've got 4 aluminum, 12 oxygen, and 12 hydrogen. All right, so aluminum is good. Well, let me look at carbon. I have 3 carbon on the left side, and I have 1 carbon on the right side. So that looks like an easy fix. If that becomes a coefficient of 3, then that gives me 3 carbon and 12 hydrogen. Okay, so far so good. Carbon is good, and aluminum is good. Now, whoops, I have a typo here. It looks like I wrote 0 oxygen. I'm not sure why that won't let me erase, so I'll just cross it off, and that should be a 1 there. So let me keep going here. So now hydrogen is in lots of places. Hydrogen is here, 1 place on the left, and 2 places on the right. So I'm going to try to deal with hydrogen last. Because if I start changing too many things with hydrogen, then it's going to undo a lot of what I've already done. So 1 oxygen on the left, and 12 oxygen on the right. Looks like this needs to be a coefficient of 12. And that will give me 24 hydrogen and 12 oxygen. Coefficients can be large. Don't be afraid of large coefficients. So that, in doing that, I fix the oxygen. So now I've got to make sure that my hydrogen works. If it doesn't, everything has gone wrong. I wrote something down wrong somewhere, right? Because if I change anything else, it's going to alter everything. So if I have 24 hydrogen here on the left, I got 12 up here on the right, and 12 down here on the right. That's a total of 24. So that works really well for me. So this 12 is going to go up here in front of the water. This 3 is going to go up here in front of the methane. And the 4 is going to go here in front of the aluminum hydroxide.